going on the inverse part of matrix algebra. So we're still going to be, so you guys essentially are learning 3 ways to solve. It's through row operations, matrix algebra. So the algebra stuff I just taught you are things you can do. I haven't taught you a way to solve a system. So today we're solving a system using matrix algebra. And then the third way will be lesson 26, which is called Kramer's rule, and it's an application of using something called determinant. So you guys could solve the system any of those 3 ways. Obviously, substitution and elimination was your first way, but the new content that they are going to probably be assessing you on is the row operations, today's stuff, using inverses, or Kramer's rule. 3 ways to solve any system. Okay. I didn't have this open. Sorry about that. All right, so we're picking up at inversions, okay? Being able to do the inverse. So we already kind of talked about this. This didn't copy the greatest, so you're going to have to make it look a little bit better, but this is supposed to just look like a 2 by 2. So 1, 0, 0, 1. This is supposed to look like, again, they switched things up, so it was taking me endless amount of hours organizing it, and I'm just going to be reorganizing it next year. So if I were to make this look a little bit prettier, it's 1s on the diagonals, 0 on the bottom and top triangles, if you know that it's the identity. So what an identity is, it's like a 1. Like if I was doing a number times 1, it would always push back that number, right? So that's what this means, is like 2 times 1 would give me a 2. So it's kind of like that's the identity, if that makes sense, okay? So for a 2 by 2, you have 1s in the diagonals and 0s up in the corners. And on a 3 by 3, 1s in the diagonals and a 0s on both those triangles of 0s, okay? If you multiply a matrix by an identity, you get the same exact matrix. And you know how we talked about multiplication is not commutative? We right before the bell rang, we did a little 2 by 2, and we multiplied a matrix by another, and then we swapped them and did it by that, and we got different matrices, right? So, hey Reed, we can prop it until it gets loud, in case people are in and out. How are you? Good. Reed's like, I really made a mistake picking a seat, huh? I wish I didn't take away the magnets, because it wasn't a problem when I had magnets, but they took them away because they weren't allowing us. So you guys are allowed to do a matrix times the identity. The little subscript n is for if it's a 3 by 3. So like this is the identity. Sorry, this didn't copy very good. This is supposed to have like a subscript 2. This is supposed to have a subscript 3. So identity for a 3 by 3 and an identity for a 2 by 2. So if your matrix is times by its matching identity, it should give you A again. Or if the identity is multiplied first, times that, it will give you A again. So I know things aren't commutative unless it's the identity. The identity can be times in any order, and it'll still give you A. So like I said, it's kind of like me doing 1 times 2. The identity could be first, or the identity could be second. But either way, we're getting the same exact thing like that. Okay. So the way we use it in matrix algebra is we use it to find an inverse. And I'm going to teach you how to find an inverse in a second. And it's actually, any of you who have been struggling with row operations, you get to practice it more. So those of you who hated it, I'm sorry. And you have to get the identity. So you're like reducing this left side till it's reduced row echelon form, which is 1s and 0s. So you're doing at least 7 rounds of row operations. Almost. So, 2 real numbers are called multiplicative inverse if their product is a 1. So what that means is, so some matrices have a multiplicative inverse. If A and B are n by n matrices and I is the identity, and if I get A times B and B times A and I get the identity, that means they must have been inverses. So I can times this matrix by this matrix and I would get 1s on the diagonals and 0s. And then if I reverse it and times it again and I get 1s on the diagonals and 0s, they had to have been inverses of each other. Okay? Matrices that give you guys an answer, like an ordered pair or triple, they are the ones that have identities. Singular matrices, like ones that don't have any solutions or infinitely many solutions, those ones would not give you an inverse. Okay? So, inverses, remember how little superscript negatives stand for inverse? So A times its inverse, that's what the inverses stand for, and then A inverse times A would be bigger than B. So make sure you realize that those stand for an inverse. Okay, so I don't know the way they will assess you. They were really nice. They did it 1 year, was it last year? 1 year, they made you just solve the system using row operations, so you guys could stop once you got triad and zeros on the bottoms and just back substitute. But they still asked an inverse question, so you still had to know inverses. Where some years when we've only had 9 questions on the test or 10 questions on the test, they just picked one way to solve a system, but that was back when it was like, we had so much content. We had like a midterm and a final. So you had a ton of content in like 10 questions. And so now that they've done 3 tests, they now can ask more, questions on each of them. And so I bet they'll ask you to do a row operations one. And then I bet they could ask a question asking you to prove things are inverses. Possibly. So we're going to do this one to prove their inverses. They might already give you an inverse and also ask you to solve using matrix algebra. I'm hoping they don't make you do a whole row operations one, but they might. So we're going to do one of those today too. Okay? Okay, let's first start off by showing that they're inverses. So how would we show their inverses? What did we just learn? Taking A times B and timesing it, and then we're also going to be having to do B times A and proving that they're inverses. Now this is a 3 by 3 times by a 3 by 3. So we're going to get a result of a 3 by 3 in the end, right? So we learned that if you're timesing a 3 by 3 by a 3 by 3, we know we're allowed to because these are the same, right? And the result will be a what? It'll be a 3 by 3. Let me see if this is something that has to happen now. Sorry, they need my help.